Hello everybody. Today we find ourselves in the deep, dank, dark dungeon known as the Signal Integrity Lab. And what is a Signal Integrity Lab? Well, it's where teachers and their grad students do research to investigate the integrity of signals as they pass through different circuits, different connectors, different conductors, different cables, different media. Basically what they're looking for is how well a high-frequency signal gets from one place to another through a certain medium, and to make sure that that signal is still intact from one end to the other. First, I should point out that this used to be a teacher's lounge. It's a very small little room, little dinky thing, and I think it was 2005 when we acquired this room for the EE department. So it still has the old fridge and microwave here. So we have a lot of fancy high-frequency equipment like this Tektronix DSA, Digital Serial Analyzer 8300, and a whole bunch of weird little RF development boards like this thing. There's certain, where you have certain RF channels, matched pairs like this going through different lengths, different twists and turns, just to, and also on different media. And this, I never seen this kind of connector before, but man, look at that. This cable alone is probably worth several $100s. And we got things like this. This is an Altera transceiver signal integrity development board. Lots of RF SMA connectors on here. FPGAs, a whole bunch of stuff. And some more weird-ass connectors on the end of it here. Super high density data connections, I suppose. I think I found the circuit board that those things plug into. It's a really thick circuit board here. Looks about 3/16 of an inch. A lot of layers in that thing. And already mounted on here is a double rainbow of SMA connectors. Really weird stuff down here. I'm no expert in high frequency RF stuff, so this is all a bunch of voodoo as far as I'm concerned. One thing I do understand is some research that one of our faculty was doing a while ago, where he had all these samples of different boards, some of them with solder masks, some of them without, probably different materials, different thicknesses, and different widths of the trace on there. There's a different material, different lengths, and there's a whole bunch of different variables to test. And what he did was he took these over to the environmental lab, put it into their humidity chamber to control humidity and temperature for long periods of time, and then to see if these boards absorb some of that humidity, which would of course change their electromagnetic properties. So that's what he did. Stuck these in there for, I don't know, hours, days, months, however long it took, and then hooked it up to high frequency stuff like another DSA. This is the Digital Serial Analyzer, the 8200 that I repaired a while ago. I found that I had to replace the computer motherboard in this thing, and I got some videos out of that. I'll link them in down below. We got some Agilent stuff over here. Let's see, what the heck is this one? That's an Agilent E8364B PNA network analyzer and an associated thing down here. I think it's an S parameter test set. Here's some leftovers from a project from a couple of years ago. These RF foam pads for absorbing RF energy, just like in an anechoic chamber, except this one has a hole in it. This foam was left over from a project from a couple of years ago where a student was doing some research investigating the RF transparency of a certain material at certain frequencies, and he would put the material right here in this hole with a transmitter on one side and a receiver on the other side. And of course you need all this RF absorbing foam all around so that you pass the RF only through the material and measure it on the other side only through the material, and that way you can eliminate any RF that would happen to go around the material, of course. And just like any good quality dungeon basement lab ought to be, this one tends to be a dumping ground for stuff that gets forgotten or left behind, like this 10-year-old computer that some student had down here. I don't know what he was doing, but I'm sure he's long since graduated, or maybe not graduated, I don't know. And we got books that never get read. There's a bike down here. Somebody left his bike and it's been here long enough that the tires have gotten flat. It's got really nice disc brakes and all that good stuff. I really hope he has also long since gone and forgotten about this thing so I can have for myself a sweet new bike. And of course, a bunch of empty cardboard boxes and packing material for some of the DSA and all these RF network analyzers and such. And there is a bunch of stuff donated from a company back in 2005 when we first acquired this lab. We also got this table, this optics bench table, huge thick slab, well, not a solid slab, it's hollow, but this big chunk of steel mounted on a big steel table with there's some air pressure stuff down inside here, and basically what it does is it levitates this whole thing on a cushion of air to isolate any kind of mechanical vibration that would go through the building and into the table. That way you can do very sensitive optical experiments on this thing without any interference from mechanical vibrations, which do exist, and certainly down here, because all the ventilation and transformers and all that stuff, that's all right next door across the hall. And the same company also donated all this stuff down here, a whole bunch of optics, fiber optic stuff and RF network stuff. And these things over here, again, they've just been down here collecting dust. And this one, you know, you need some kind of heads to put in there, and I don't think we got any of the heads with it. It's just a big dummy terminal right now. What is that? Communication signal analyzer. This one is a optical spectrum analyzer. So when we move to the new building, which is going to have a much, much larger room than this one, the signal integrity lab is going to be, you know, like a full-size classroom size, probably 4 or 5, 6 times bigger than this. And adjoining right next to it is another small research lab about the same size as this one, a little bit smaller, but basically this is going to be like the research lab, the small little dinky research lab in the new building, and there's going to be a much larger signal integrity lab that will be attached to it. But anyway, I'll have to go through all that equipment to see what we can use and what we can't. So that's the signal integrity lab. Not much to look at now, but in the near future it will be a lot nicer, a lot bigger, and a lot more spread out. And I think we're getting some new equipment too. So we'll see how that goes. See you later.